Welcome back, student. Now today we'll start a new chapter, that is fuel and combustions. Okay, and the name suggests that fuel and combustions, and as you know that fuel and combustion basically they are parallel term, fuel and combustion. Okay, now first of all we have to know that in fuel and combustions what are the topic we are covered. So in fuel and combustion chapter we will study on that what is fuel, what are the different types of fuel, and types of classification of fuel, and what are the sources and what are the properties of particular different types of fuel like solid, liquid, gaseous types of fuel. Okay, and we also calculate the heat formations, means enthalpy during the reaction. Okay, means by means of Gibbs free energy. So there are the lots of other thing also we have also calculate. Okay, and calorific value means HCV, LCV. Okay, and as well as there are some other topics that we can cover also in this chapter. Now first of all we have to know that what is fuel. Now fuel is basically a substance. Okay, fuel is basically a substance that is basically done by some way that it is basically formed some amount of heat energy or any other type of energy. You can say that may be different types of energy, it may be, or it may be electricity, but this type of energy which is basically generated by the combustion of fuel, we generally used in our normal daily life as well as in industry applications also. So this is the needful of fuel, and this is the needful purpose or actually of combustion. So fuel is basically important factor in our important tool. You can say that it is, or you can say that it's a substance. Okay, that is basically used in our combustion process takes place, when the combustion process takes place. Now, so fuel can be divided in different categories, but depending on the applications, depending on the construction features of fuel, that fuel may be two types: chemical fuel as well as nuclear fuel. Now chemical fuel is basically, as the name suggests, that chemical fuel. Okay, so obviously main is that it's release heat energy. Okay, it's release heat energy when the combustion takes place. You release heat energy by means of by some means of chemically reaction. When the chemical reaction takes place in between fuels and other combustible matters with presence of air, so obviously they will produce some amount of energy. So that type of fuel is basically chemical fuel. Okay, and main principal combustible element, that is basically your maybe your carbon, hydrogen. So these are the main hydrocarbon element which are basically present in our chemical fuel. But sulfur also present chemical fuel, but that is not desirable for any combustible element. Okay, but but it is not actually desirable also. Now nuclear fuel. So but the chemical fuel is in a syllabus, we just study on chemical fuel. But what is nuclear fuel? This nuclear fuel is that type of fuel basically that is used in our nuclear power plant or nuclear power stations to produce actually heat or to produce power to the turbines. Okay, so that is like you can give example like for nuclear fuel like uranium-235. You know that this is a radioactive element, that is U235, uranium-235, or plutonium that 239. So these are the used as the nuclear fuel in our nuclear power stations. So that type of fuel is basically called nuclear fuel. And is in case of chemical fuel like your coal, coke, and diesel, petrol. So these are the normal, which is basically used in our normal daily life, or which is basically used in our normal industrial applications. So that is basically chemical fuel. So depending on your classification of fuel, if you divide or classify the fuel, basically depending on if it is occur in our nature, that is called primary fuel. If it is prepared by some means of processing of natural fuel, then it's called secondary fuel. Now, what are the types of fuel? That is, first of all, solid fuel. It may be called as solid fuel, liquid fuel, and gaseous fuel. If the fuel is solid, that is called solid fuel. If it is a liquid, that is liquid fuel. If it is a gaseous, that is called gaseous fuel. That means fuel is, if in the form of solid state or solid in nature, that is called solid fuel. If the fuel is in liquid in nature, that is liquid fuel. If the fuel is in a gaseous form or gaseous state, then it's called gaseous fuel. Okay. Now, some example of solid fuel as primary as also secondary. Wood, peat, lignite, coal, charcoal, coke. So these are the actually solid fuel, but there are some primary, there are some secondary. As you know, that primary basically occurs in our normal nature, okay, which is basically occurs in our nature, but secondary fuel is done actually is processed is prepared by some processing of natural fuel, okay. Liquid fuel is basically natural is basically petroleum. For secondary, that is gasoline, kerosene, fuel oil, and alcohol, benzol. So these are the secondary fuel. And gaseous fuel, that is natural gas. It is basically your primary fuel, but when you do a secondary fuel, that may be petroleum gas, producer gas, coal gas. So these are the solid, liquid, and gaseous fuel. So we'll discuss on elaborately on primary fuel like wood, peat, lignite, coal, petroleum, natural gas. What are those actually? We can discuss on that on the next slide. Okay. Okay. Now, solid fuel. So as we know that fuel is basically there are three types: solid, liquid, and gaseous fuel, depending on the conditions of the fuel. If it is in solid in condition, solid fuel. If it is in gaseous condition, gaseous fuel. Okay. Now, solid fuel is first of all is coal. So coal is basically also one type of solid fuel. As you know that coal is basically hard rock. Okay. So basically hard rock or main constituent element that is coal, that is carbon, and there are others element also are there. It may be hydrogen, oxygen, nitrogen, sulfur, and some amount of moisture, ash. So this type of element are present in coal. It's a hard rock, and as you know that coal are basically there are four types of coal. It's a peat, okay, peat, lignite, bituminous, okay, and anthracite. So these are the four types of coal, as you know that. So now, first of all, plant. How do you proceed that coal? So first of all, plant reduced to peat, peat to lignite, lignite to brown coal, sub-bituminous coal, bituminous coal, semi-bituminous coal, semi-anthracite, anthracite, okay, anthracite. Then it is graphite in the form, as you know. So these are the form of different types of coal when you process some by some processing, okay. So that is the different types of coal are there. So first of all, peat. So peat is actually not a coal. Peat also one type of coal, but peat is something where the mainly non-volatile matter present is very much high, okay. And it's a fast stage from wood, and there are huge amount of moisture. Because of the presence of huge amount of moisture, there are less they produce less amount of heat energy or energy, you can say. And so that to increase their efficiency, you can use for dry for 1 to 2 days, okay, so that the moisture amount or huge amount of moisture is released and the quality is increased. So peat is that type of coal, okay. And lignite also the second type of coal, and there are some all there, as the name suggests. It is also sometimes also called lignite, also sometimes called brown coal. Now the brown coal is called basically because of their flame that produce. So it's basically brown in color, and their appearance is basically woody appearance or gray in appearance. So that's why it's called brown coal, okay. And it's in this type of coal also the high amount of moisture also present, but less than the peat. As you go progress from peat to lignite to bituminous to anthracite, the moisture presence in the particular type of coal is less and the quality is increased. So in among of them, the quality is very much high, is basically your anthracite. Now, so high moisture there in lignite, high moisture also present as low heat content. So as that is amorphous. So as you know that material is two types. So amorphous type of materials where the crystal arrangement or arrangement of the materials or atoms are not in regular way, that is called amorphous. So it is basically brittle in nature, so it is easily breakable. So there's some problem in transportations, okay. So if you transport this type of coal on from one place to another place, they will produce there some small amount of means the small size of coal that produce, okay. And bituminous also burns long yellow flame. So As you burn progress or different types of coal, so obviously in the bituminous type of coal, the moisture present is less and it burns long yellow flame, high percentage of volatile matter present. So and at that particular time also you can divide on that coking coal and non-coking coal depending on the pressure and heat also present or not on your processing. Okay, so that is bituminous coal. As you go increasing heating and pressure, heat and pressure corresponding to this, you will produce a grit to lignite, lignite to as well as bituminous to anthracite, then after all graphite, as we know. So semi-bituminous also one type of coal in between bituminous and anthracite. It is basically softer than anthracite, and there is small amount of smoke. And anthracite basically hard in nature and high amount of volatile matter is present. Also, there are less amount of moisture and it produces high amount of heat. Okay, and as well as it ignites high blue flame. So these are the properties of anthracite, which is basically a form of different types of coal and which is used as a solid fuel, all of them. And coke also used as a solid fuel. So coke is basically mixture or the presence of that is carbon, mineral, 2% sulfur, small amount of hydrogen, small amount of small amount of hydrogen, nitrogen, and phosphorus. Okay, so these are the elements are present, and it is coke is basically used in our blast furnace. Okay, so these are the solid fuel, as you know, and now we'll discuss on actually on liquid fuels. Okay. So these are liquid fuel. As you know that fuel is there are three types: solid fuel, liquid fuel, and gaseous fuel. Now we'll discuss on liquid fuel. And in liquid and gaseous fuel, main liquid fuel is that petroleum. As you know that petroleum is very familiar with the name that petroleum, which is basically is another name that is also called crude oil, as well as it is also sometimes called fossil fuels because it is being originated from because of fossils. Okay, that's why it is sometimes called crude oil or fossil oil, or it can be sometimes also called petroleum. Now, its main source is that earth crust. Okay, but there are different opinion regarding the origin of the petroleum. Okay, but most of the opinion is that that it is probably from organic matter. It's originated from organic matter like fossil fuels, all these things from the earth crust. It is basically from this petroleum, which is in earth crust. Okay, but the main source is that for the liquid fuel is that Assam and Gujarat in India. So the main source in India is Assam and Gujarat for petroleum. Okay. Now, what are the advantage of liquid fuels over solid fuels is that number one is require less space for storage. Okay. Second point is high calorific value. Third one is easily control of consumption. Fourth one, easily handling or transportation. And obviously the cleanliness. So these are the main 4 points or 5 points that gives you the advantage of liquid fuels over solid fuels. Because in case of solid fuels, there are some we can say the limitation are there. There's some disadvantage, but in these liquid fuels, there are a lot more advantages like less space for storage and obviously the transportation, easily handling, and the calorific value, which is very important for any fuels, because if any fuel has high calorific value, that means it can produce high amount of energy for combustion of kg of fuel, liter of fuel. So these are the important points when you consider a particular it is a liquid, gaseous, or solid fuel. And next one is gaseous fuel. So gaseous fuel is that type of fuel is basically in the form of gaseous state or vapor state or gaseous form. That is called gaseous fuel. Now, natural gas is one type of, you can say, gaseous fuel. Now, natural gas like methane, ethane. So all this type of fuel are basically natural gas is basically gaseous fuel, and it is the calorific value is very high compared to the liquid fuels. That is 2100 kilojoule per meter cube. And there are lots of other gaseous fuels like coal gas, coke oven gas, producer gas, water gas. So as you know that coal gas basically is a composition or constituent of carbon, means carbon monoxide, hydrogen as well as hydrocarbon. Okay, hydrocarbon means, as you know, that there are some carbon and hydrogen component are there. So hydrocarbon, and it is used in boiler. So boiler basically, why it is boiler is used, boiler basically used in thermal power plant. So all this steam power plant actually. So all this plant in the plant is a boiler basically used. In that particular, when you produce some water to steam, in case of steam power plant, we can use it as the external source of heat as a coal gas, okay, which is a mixture or constituent particle is hydrogen, carbon monoxide as well as hydrocarbon. Okay, now coke oven gas is obtained during production of coke by heating bituminous coal. As you know that coal is basically, there are four types: peat, okay, peat, lignite, and bituminous and anthracite. So in between, out of four coals, there are bituminous coal, which are basically when you heating this particular bituminous coal, that are obtained that during production that particular type of coke oven gas. Okay, now producer gas, that basically partial oxidation of coal, coke, or peat when they are burned with an insufficient quality of air, they can produce a producer gas. It's a low heating value, and it is used in steel industry. Now water gas. Water gas basically produced by blowing steam into white hot coke. Okay, and what are the advantage of gaseous fuel? Is gas main advantage is the better control of combustion. Because a better control of combustion is very important, very advantage. Secondly, no problem in storage. So in case of solid or liquid, that may be one problem, is that storage problem. In basically storage problem is occurs in solid fuels, but in case of liquid and gaseous fuel, there is no storage problem as well as transportation problem also. But in case of transportation, there one problem is that if the leakage is occurred, so they will burn. Okay, so economical as well as less space required or less excess air is required. Now we will discuss on excess air, which is very important in the context of fuel and combustion chapter, because as you know that theoretical air and excess air, there are two terms. The theoretical air, as you know, that in case of combustion or in case of fuel and combustion, obviously there are some oxygen presence very much needed because for the combustion process takes place. So what are the amount of air is required as theoretically, that is called theoretical air, but that is not sufficient for any type of fuel combustions, any type of combustion of fuel. So that's why there are some excess amount of air is required, which is greater than the theoretical air. So that is basically excess air. But in case of gaseous fuel, that percentage of excess air is less in case of gaseous fuels. But we will discuss elaborately when you discuss theoretical air and excess air and stoichiometric ratio. Okay. Now combustion equation. As you know that fuel there are three types of fuel: solid, liquid, and gaseous fuel. And there are different types of solid fuel, liquid fuel, and gaseous fuel, as well as primary fuel, secondary fuels. So all these topics you already covered. Now combustion equation, because the combustion takes place because when the fuel is passed through a particular area or combustion chamber, when the proportionate amount of fuel and air is passed through a particular combustion chamber, and there will some point where the ignition start by means of ignition igniter. So their combustion takes place. Now the chemical reaction takes place, that is basically done by hydrogen plus oxygens. Okay, but as you know that in a combustion of equation and total conservation of mass of energy, from the conservation of mass of energy or conservation of mass, you know that total mass of reactant, because in combustion equations or any type of chemical reaction process, there are some reactant are there are some product are there. So when the reactant and product are there, what is the left side and the other right side of the particular equations, so if you apply on the analysis is conservation of mass, that means the total mass of reactant should be equal to the total mass of product. Okay, means after reaction what are the product takes place, that is the total mass. If you assume the total mass and the total mass of reactant, it should be equal on a particular pressure and temperature compositions. Now But what happens that when the reaction takes place with proportionate amount of air with fuel, if the proportionate amount of air is mixed with fuel and the burn takes place, so obviously if the sufficient amount of air is there, that is called basically complete combustions. If there are some amount of means there are some less amount of oxygen which is basically required for the fully combustion of fuel, if there are some less amount of there, so obviously that is called incomplete combustion. But what happens when the reaction takes place, that obviously the reaction, there are some reactant, there are some product are there. In the left side are reactant, others generally in right side are the product are shown in your chart. So obviously it should be equal. But after reaction, what takes place, the atoms, the basically the in the reactant, in suppose these are the reactant, these are the product. In the reactant, these are two there are two different atoms, these are the different atoms. But after reaction, it should be the atomic arrangement, the total means in the combustion chamber, the product and the reactant, the total number of atoms is constant. Okay, but after reaction, what happens? They are chemically defined, they will form a different chemical compositions. But so that if there are some difference in atomic arrangement, so it should be it should be equal in as well as from left side to right side, so that it follows the consistent in left side to right side, so that it follows the total mass of reactant is equal to total mass of product. So it should be followed. So as you know that in case of combustion or in case of dry air analysis, there in our normal atmospheric air there are 23% basically are 23% are basically by volume, actually oxygen are present. In case of 76% are nitrogen are there. Similarly, in case of combustion analysis, you can see that in case of by mass analysis, the 21% of oxygen are present and 79% of nitrogen are present by volume basis. So in case of dry air, in a dry air, okay. So this to be has to be in your mind, that 79% nitrogen and 21% of oxygen by volume basis they are present in case of fuel when you analyze fuel combustions. Now, and obviously when the oxygen react with some actually when the oxygen react with the fuel, so obviously there are some nitrogen will be included, because there are some atmospheric nitrogen up there, because there are some nitrogen which basically is basically are within oxygen, so that is basically atmospheric, so that is basically atmospheric nitrogen. So now as you know that in combustion process, when you analyze these things, so first of all we have to analyze the combustion of hydrogen, combustion of carbon with obviously oxygen, because oxygen is the main agent to react with the volatile matter, means of hydrocarbon. So first of all, as you know, the hydrocarbon main compound is carbon and hydrogen. So oxygen has to be react with the hydrogen or carbon separately. So obviously, if the combustion of hydrogen takes place, so if the 2 hydrogen plus oxygen is equal to 2 H2, as you know, so that indicates, so that equation gives you the idea that if hydrogen react with oxygen, it forms steam or water. Number 2, that 2 moles of hydrogen, so that means 2 moles of hydrogen, 2 volume mole of hydrogen react with the 1 mole of oxygen, that produce 2 volume means 2 mole of water. So that by means of proportion of mass and by proportion of volume, if you analyze this, you can see that 2 hydrogen plus oxygen plus 2 H2, that molecular weight, that hydrogen 2 into 1 plus 2 into 16 of oxygen, that will be 2 into 1 plus 16. So 4 kg of hydrogen plus 32 kg of oxygen equal to 36 kg of water. If you divide with 4 in both sides, in the left and right side, that will be 1 kg of hydrogen plus 8 kg of oxygen is equal to 9 kg of water. So in by mass proportion, it obviously follows that 9 kg of reactant is equal to 9 kg of product. So it follows the conservation of mass. Okay. Now obviously, so that it can follow, that's why it is balanced, that 2H2 here plus O2 plus 2H2O. That's why that is consistently required for the consistent. Okay. Now, from the equation 1 means this is the equation 1 that volume that from these equations idea is that total volume of reactant is here 2 plus 1, that is 3 volume of reactant, but the product is 2 volume. Product is 2 volume. So that indicates there is some volumetric concentrate, means a contraction, actually volumetric contraction on combustion. When the combustion process takes place, if you analyze on by means of volume, so there are some you can say that uh, there are some contraction, volume contraction on combustion. Okay, now you can adjust because as you know that in case of oxygen, when oxygen is accompanied by nitrogen, because there is some nitrogen present because there is some atmospheric nitrogen. So when oxygen is accompanied by nitrogen, if air is supplied for the combustion, so obviously it should include that there are some nitrogen also present. So nitrogen should be included. So 1 mole of oxygen, there are 79 by 21 mole of nitrogen. Okay, so that's why the final expression will be 2H2O plus O2 is equal to 79 by 21. Nitrogen is equal to 2H2O plus 79 by 21 nitrogen. So these are the combustion of hydrogen. Now we look into this combustion of carbon. Okay. Now combustion equation for complete combustion and incomplete combustion of carbon. Now combustion of carbon. Okay. In the combustion of carbon means when the carbon is react with the oxygen, means atmospheric oxygens, that will be formed in case of complete combustion, carbon to carbon dioxide. So C plus O2 is equal to CO2, as you know. So C plus O2 is equal to CO2. Now when you not included atmospheric nitrogen, that is 79 divided by 21 into. Now if you here included that nitrogen, that equation becomes, the equation means combustion equation becomes C plus O2 plus 79 by 21 into nitrogen is equal to CO2 plus 79 by 21 nitrogen. Okay. Now by volume, so this is the expression of combustion equation. So this is the zero volume of carbon is here, it is 1 volume of oxygen, because here is considered zero volume. If you consider by means of volume and by mass, so by means of volume, 0 volume of carbon plus, because the volume of solid is negligible. Volume of solid is negligible compared to the volume of gas. Okay, so that's why the 0 volume of carbon plus 1 volume of oxygen plus 79 by 21 volume of nitrogen is equal to 1 volume of CO2 plus 79 by 21 volume of nitrogen. Okay. Now, if you calculate in case of mass basis, the final expression, combustion equation expression will be that here 12 kg CO plus that will be 32 kg oxygen plus 105.3 kg nitrogen is equal to this one. Okay. Now here it is for incomplete combustion. Incomplete combustion. When the incomplete combustion takes place, so first of all, when the carbon reacts with the oxygen, they will form carbon monoxide. Then after all, that carbon monoxide with plus nitrogen, that will react with the another available, means excess, then available oxygen, with react with the excess oxygen which is available, then it will form carbon dioxide. Okay, so here 2C plus O2 in case of complete combustion, first it is from carbon monoxide. Now in case of incomplete combustion, if you calculate or when you include that nitrogen, the equation becomes this one. Now if you calculate in terms of mass basis as volume basis, the equation becomes this one. So 1 kg of C plus 4/3 kg of O2 plus 105.3 by 24 kg of nitrogen. So that will equal to 7 by 3 kg of CO plus 105.3 kg of nitrogen. Okay. Now if the further oxygen is available, now the equation becomes 2CO plus O2 plus 79 by 21 nitrogen. That equal to becomes 2CO2 plus 79 by 21 nitrogen. So this is the combustion of carbon when the incomplete combustion process, incomplete combustion of carbon and the complete combustion of carbon takes place. In case of complete combustion of carbon, the carbon is produced, or means carbon is transformed into the carbon dioxide in case of complete combustion in one state, but in case of incomplete combustion, the carbon is transformed into carbon monoxide, then with react with the oxygen, then again it will form carbon dioxide. So this is the final expression of combustion of carbon, and the previous was that the combustion of hydrogen. So these are the combustion equations. Okay. Now in the next lecture video, we'll discuss on the theoretical and exercise, which is very important in case of in the context of fuel and combustion chapter, stoichiometric ratio, equivalence ratio, and combustion analysis. So all those things will be discussed in the next lecture video. Okay, thank you very much for listening and watching me, and goodbye.